Okay guys, this video is for 1-3, the test that we're getting ready to have on tomorrow. We could not push back that exam. We needed to go ahead and take it to stay on top of the lap. And again, we missed 2 sessions together, certain groups. So that's why we're trying to stick with the schedule with 1-3. However, this will give me enough time to input all the grades, and then October 15th is when the report card will be due, or the final grades for the end of the quarter. So we will talk about if there is some retest opportunity if this test doesn't go good, or even if you want to retest over 1-2. So again, we'll play it by ear. We'll get all your points in. We'll get your grade up to par, like with everything inputted. And then we will move from there to see what we can do to have good averages for the end of the quarter, or by the end of the quarter. All right, so this is the answer key. Oh, where's my little stylus? Give me 1 second. Oh, I see. Let me go to here. All right, so in this window, this is going to be the answer key. This video is to help with giving explanations with all of these problems that are here. And then I have now got a copy of what the actual test looks like. So I will talk to you about what I've seen. Let me close that. Sorry about that. All right, so let's talk about solving matrix equations. So when I look at this, the first thing I would do, again, I'm thinking, hey, I'm solving a matrix, all right? So in these corresponding positions, I will sit back and I will, have to do something with making an equation because of those corresponding positions, like you're solving an equation. However, I noticed that on this one, there's a -1 being multiplied like a scalar through this matrix. That does not mean that there's a -1 being multiplied also by this matrix over here. Okay, if that -1 would have been in front of here, then that -1 would get distributed between both of these, like the distributive property. So I just wanted to throw that in. So again, that is not there. All right, so the first thing I would do is write down the matrix that's on the left side of the equal sign, just like it is. G 7 equal. And then on this matrix right here, I want to multiply -1 times each of these individual values. So here I would get -1 times 0 is 0, -1 times -1 is 1, -1 times -5 is +5, -1 times 3 is -3. Okay, then I'm going to add, and I'm just going to drop this matrix just like it is because there's nothing happening. Plus y, 6, and -2x. Okay, and just for a moment, I'm going to erase out that arrow so it's not in the way. Okay, all right, so now let's look at our equations. So I'm going to come in with, if I can, another color. Let's go to, okay, so now I'm going to take this one equal to this, equal to this. All right, so I'm going to have 3 is equal to 0 plus 7 plus v. Okay. And that's pretty straightforward. We're just going to subtract 7. So I got v is equal to -4. So I'm going to write that up here. Okay, now I'm going to erase and go to my next variable. So I hope that makes sense. You're just solving for v. Okay, now I'm going to come back here, get rid of this line, and this one, and this one. And again, for this one, there's a 2, a 1, and then an x plus y. So I have 2 equals 1 plus x plus y. Now in this case, you can subtract the 1 over. So now you have, and I'm just going to write this kind of down here, 1 is equal to x plus y. But because you have 2 unknown variables, you can't do anything with that. So we just got to pause for the cause right there, and then just keep going and look at our other variables. All right, now I notice, again, I'm going to erase the green line. So now I'm going to take this guy equal to this. Again, all I'm looking at is corresponding positions. So in this one, I'm saying I have the square root of g, which is equal to, and then I have 5 plus 6, which that's 11. Okay, and I'm solving for g, so we want to square this, and what we do to one side, do to the other. So now, again, g is just 121. All right, so I'm going to write that up here. That's that. So I'm going to erase. Okay, and now we're going to do that last piece. Now the good thing about the last equation we're going to set up is you notice that it has an x. So when I do 7 equal to negative 3, and then there's the x. See, I can go back and get y. So the setup here is 7 equals negative 3 minus 2x, add 3. And again, I hope you're still listening, because that's one of our issues. Is everybody keep listening to the teacher, all right? Is that if you are having a problem looking at this from left to right, and you're used to your 7 or your equations having the equal sign on this side, and your stuff is on the left side, then you orient it how you feel comfortable, okay? So that's just me making a side note. Now I'm going to divide by negative 2. So we should have got basically x is equal to negative 2. Okay? So now that takes care of that. And then yes, I can go back now to that bottom equation and I can get y. Okay? So I'm going to erase all this. Erase also these lines here. And now I have 1 is equal to negative 2 plus y. Add 2 to both sides. So y is equal to 3. And again, that's what I meant by orientation. You can just rearrange it. So now you have all 4 of these problems. And if you were on a sheet of paper or something on the test, you should be able to, again, show all your work in detail and just be careful with your arithmetic. All right, so that takes care of number 1. Let's move on to solving by graphing. Okay. All right, so now I'm going to scroll down if I have enough room. Again, I would write this right here. Okay, so on this one, solving by graphing, change them both into slope-intercept form. So for this one, you should get, I'm just going to kind of do this in my head, but I will show my scratch work. I have negative 4y equals negative 5x plus 3. Then I'm going to come back and then I'm going to divide everybody by negative 4. So I would get y is equal to a negative divided by a negative is a positive. So this is positive 5/4 x. Divide this guy by negative 4 and get negative 3/4. Okay. Somebody did ask me that came and talked to me after school, which was great. You know, hey, do we have decimals? Well, yeah, it's fair game if some are whole numbers or decimals. So again, this one, you have to be comfortable with fractions and decimals and whole numbers in math, right? So 5/4 x minus 3/4. Okay, so for this one, like I said, we have to deal with decimals in just a second and fractions. All right, so now let's talk about the next one. I'm going to erase this over here. And I'm going to change the next equation into slope-intercept. So here, I'm going to do my work here. 2y equals negative 3x plus 15 divided by 2. Okay, so now this becomes y equals negative 3/2 x, and this is going to basically be 7.5, but we can leave that as 15 over 2. And again, I know that that's 7.5. That's why, again, be comfortable with fractions and decimals. All right, so now that we have our 2 equations in slope-intercept form, I'm going to zoom in here just a second. I may have to pull up another slide so I can have the whole graph, but let me see if I can get it all on here. Okay, so this right here I already know is negative 0.75 as my y-intercept. So that means that if this right here is negative 1, and then I know in between here, I hope you can see the little dot, is negative 0.5. So negative 0.75 is somewhere right really close to negative 1. I'm going to draw it nice and big right there. And the address, my m, is saying, hey, I want to go 5 up and 4 to the right. Okay, so from this spot, again, I'm trying to think about this, you know, mathematically. So if I add 1, everybody pay close attention to this. If I want to go up 1, I'm adding 1.00 to this decimal. And then basically I'm doing subtraction, so that leaves me with 0.25 negative. I'm sorry, positive when I do the subtraction. So that means what was here, and this is 1, would just be right here, a hair from this 0.75, and I jump up 1, I'd be at 0.25. So I'm going to put a little dot like right here. And then again, I got to do that 5 times. So then if I add another 1.00, that's 2.25. Sorry, 1.25. So then what was here, I'm a hair above here at 1.25. And if I add another one, I'd be at 2.25, right? 3.25. 4.25, 4.25, and let me see if I put a dot, and let me check my jumps. So again, I was here, I went up 1, 2, 3, 4, and then that's where I would end up if I went 5 up. Now I need to go 4 to the right. So here, I'm going to go to the right, 1, 2, 3, 4. Again, this is all about taking your time. So really where we want to be is right here. We can erase those other lines so it's not in the way. And again, because it's an equal sign, this is just a solid dot. So if you try to ask me, well, Miss Mosley, you know, I drew it, you have to show very carefully that you're at the right positions. And also, if when I was y'all's age, we put our coordinates right on the side of our lines, okay? So I would tell someone that, hey, to get credit, this is 4, comma, and I would say, hey, I'm at 4.25, so that someone can see that I went through that point and I didn't just sketch or be sloppy. Then I also would tell someone right here that my y-intercept is the 0.75. So I'd say right here is 0, comma, negative 0.75. All right, and then that gives you full credit for that line. Okay, so now let's do the other one. I'm going to erase everything around and go to another color. Okay. Okay, so now I'm going to change colors, undoing this stuff here around, and let's focus on the second one. Okay, blue. All right, so now again, I said this right here is 7.5. So then I'm telling myself that 7.5 is, this is 7, here's 8, so that's right in the middle here. I'm also paying attention to the fact that, you know, this one had a positive slope, and yes, I ended up in green being going up and to the right. This one has a negative slope. Now the address on this one says I have negative 3 over 2, so I'm going down 3, and then I'm going to the right 2. So again, very carefully, I'm at 7.5, and I want to jump down 3. So if I take 1 away, 6.5. I take 1 away, 5.5. I take 1 more away. I'm running out of screen here. I'm at 4.5, and that should make sense, right? So I'm saying I was here at 7.5. I'm going to go down to 4.5, which is right about here. Put a little dot in the middle, and then I want to go 2 to the right. So from here, I'm going to go 1, 2, and be right there. And then I would just connect these the best way I could. Again, use the straight edge, or if you have a ruler, like that. Okay. And so I would also put my points. So for this one, again, this is 0, comma, 7.5. And this one is at 2, comma, 4.5. Okay, I hope that makes sense. All right, so now for the point of intersection, which again, sometimes you get really lucky and you can just see it, but again, be very careful. And this is, again, this is stylus I'm using, it's kind of fat, but I see the intersection happening. Again, I may be a little off because I noticed that my line's not very straight here. That green one, I can tell, but I think their point of intersection is right there. And that's why the answer to this one is 3, comma 3. So again, right here, see? 0, 1, 2, 3, 1, 2, perfectly 3. All right, so the answer to this one, 3, comma 3, is their intersection point. All right, so again, I'm erasing everything out the way. You can stop and replay the video and pay close attention to decimals and fractions, because you can't say, oh, we didn't go over it or whatever, because I'm just saying it's fair game. All right, so again, the solution, I'll just write it right here, 3, comma 3. Be very careful with your graphing. Don't ask me why did I get 1 point off here and there. You have to perfectly do it. Label your points on your line so you can show that you graphed it properly. All right. And you can check, right? I could plug in that point for x3 into here at the top one here. I could plug 3 into here, and then that better equal 3, and I can plug in 3 here, and then also for y3, and it better equal 15. That is the point that satisfies both of them. That's another way to check. All right, let's go to the next one. All right, for this one, same thing. This one, I already see I have y is equal to negative 2x minus 5. That makes me happy because they're whole numbers. This one, however, it has no y in it, but we're still going to subtract 3. Subtract 3. And now we have negative x is equal to positive 3. But when I divide by negative 1, because there's no such thing as negative letters in the alphabet, this becomes x equals negative 3. Okay, so I have one that's a vertical line. Remember, when x is equal to a number or some kind of constant, it's vertical. So at negative 3 right here, very carefully, I'm going to just put, and I extend it all the way here to here. And then I would tell someone, hey, this is x equal to negative 3 in blue. Okay, I'm going to erase and change colors real quick. You know, I'm trying to work with my stylus here. I'm going to erase this out the way. I just don't want that there. Okay, so I'm going to go back to red. All right, now let's graph this top one. So I'm going to go to negative 5 for my y-intercept. And again, my address, m is equal to negative 2 over 1. So we're going to go down 2 and 1 to the right. So from this point, let's go down 2, 1, 2, and then 1 to the right. Oop, right there. And because I'm about to run out of screen room here, I can go back to my y-intercept and go up 2, 1, 2, and then 1 to the left. As long as my address ends up being a negative 2, right? So for this one, again, I am going to run off the screen, so I'm going to put an arrow very carefully. I'm going to go here. And to the best of my ability, I believe I would go through there. Probably not drawn properly. Let me see something because I'm at a bad angle. So, you know what I would do too? I'm going to erase. And I'm just going to do one more point. Again, you always go back to the y-intercept and do the address. So here again, I go up 2 over 1. I'm going to do it again from this point here. I'm going to go up 2, 1, 2 over 1. And I'm going to do it again, up 2 and over 1, and I'm going to go through about right here. Now I can see it even better. Okay, and then I'm going to draw my line. Okay, so for this one, I see it better, and I think I did good the first time, but again, it doesn't hurt to keep going so you can see it better. But I believe this point here is negative 3, comma 1. Okay, so that's the solution for this one, negative 3, comma 1. And again, like I just said earlier, you can check. Plug in this for x into both equations. Plug in this for y to both equations. Again, the second one does not have a y in it. All right, so as soon as you plug in your x value, it should just work out, which it will. I'm just going to show you real quick. So there's a negative on this x. Your x, we said, was negative 3. That changes into a positive 3 plus 3, which does equal 6. Okay, so again, that point needs to satisfy both equations. All right, that takes care of that. Okay, so the first video, I'm going to cut it at about 20 so minutes. So I'm going to get through the whole first page, and then that'll be one video clip, and then I will make another second video starting at number 7 if I get this all done within less than 23 minutes or so. Okay, all right, so I've taken care of number 1, 2, and 3. So again, what's going to be on your test, you can see so far, is solving by graphing. Okay, and then of course number 1, using a matrices to solve for equations. So now let's talk about this right here, and I'm going to label this again from the notes. This is about classifying. Let me pick a color. Classifying systems. So this is the part when you look at the slide where I drew everything out and I talked about what happens when I have no solution, one solution, infinite. So those words are up there, and you have to classify as consistent, dependent, consistent, independent, and then inconsistent. So let's talk about this one right here. When you're consistent and dependent, that means you have a solution. When you say it's dependent, it has infinite. So let's write them right below their classification. So this one has infinite solutions. I'm abbreviating. All right, if I'm consistent and independent, that means I have only one solution. And if I'm inconsistent, that means I have no solution. So again, keep that stuff straight, and I did emphasize that in class. All right, so the way to be able to determine what kind of system you have, you basically need to change both of your lines into slope-intercept. Now let me also say this before I start. Please do not let the wording, when it says without solving, all that's saying is that it doesn't mean look at the problem and just do it mentally. You can't solve anything. You can't move stuff around. This just means do not give or solve for X or Y. Okay, so you do have to manipulate these lines to sit back and get solutions so you can classify the system. Okay, all right, so again, I'm going to come here and I'm going to change them into slope-intercept. Move a little quicker now. All right, so now I have negative 2y is equal to negative x plus 2, dividing by negative 2 to all your terms. So this top line is going to change to y equals positive 1/2 x minus 1. Okay, that's the top one. Now I'm going to go to this bottom one, and I have negative y is equal to negative 2x minus 5, divided by negative 1 to each term. So this becomes y is equal to positive 2x, right, plus 5. All right, so now when I'm looking at everything, I just want to look at my M1 and my M2. So let me change colors. So I have basically M1 is equal to 1/2, and it's positive. And then I have that M2 is equal to positive 2. So because these guys are different, okay, that means at some point they would intersect, all right? So because M1 is not equal to M2, I'm going to classify this one not as infinite, because infinite would mean that we are the same line, which means our slopes would be the same and our y-intercepts are the same. So I hope you're listening when I say that, okay? And then if I say I have one solution, then I'm consistent independent. So that's what this one is. They have at least one point of intersection. So I'm going to say number 4 is consistent. And I'm going to say it's independent. And you could put the and symbol. I can't spell independent right now. All right, keep in mind, teacher's always really tired. Okay, so that takes care of number 4. All right, let's go to number 5. For number 5, same thing. Let's change into slope-intercept. So for that top one, 8y, negative 4x plus 8. Divide by 8 to everybody, and I would get y is equal to negative 1/2 x. And again, I'm dividing by 8 over here plus 1. So that takes care of the top one. For the bottom one, I have 2y is equal to negative x plus 6. Dividing by 2 to everybody. And then this one will become y equals negative 1/2 x. Okay, so my slopes are the same. And then I have this plus 3 back here. Okay, so now when I look at these, and again, I know that I put this work in between, but again, we're focusing on our slopes. So in this case, we have M1 is equal to M2. So they are equal to each other, which means they're parallel. And however, our y-intercepts, though, I'm going to circle this back here, are different. So because our B1 is not equal to B2, right? So our y-intercepts are not equal, and then our slopes are the same. This one would be just parallel lines, okay? So if they're parallel, no solution. So this one is inconsistent. Remember, if they are the same line, then their slope-intercepts, their slopes would be the same, and their y-intercepts would be the same. All right, so that takes care of number 5. Inconsistent, again, no solution. You can also write this wording with it as you classify it. All right, and for the last one, I'm going to try my best to squeeze this one in. I'm going to change colors. I may have to erase something. Let's go with blue. Okay, so for this one, let's see if I can come this way. This one changes into, and I know everybody knows how to move it around, so let's just put the answer, or our slope-intercepts. Y is equal to, we got 3/2 x plus, and I like to do it vertically, 15 over 2. This one is just going to be y equal, take your time with the fraction. Matter of fact, let me show that one just in case. I want anybody to act like they, nobody showed them this. So let's go. This one, again, I'm going to just leave this as negative 2/3 y equal negative x minus 5. To get rid of this negative 2/3, I'm going to multiply this side by negative 3 over 2. And then I have to multiply everything on this side by the same thing, negative 3 over 2. It's really small, sorry. All right, so this right here would be, again, positive 6 over 6, which is 1. So that leaves me with, I'm going to read right here, y is equal to, but then I got to do the distributive property right here. So that negative 3 over 2 with this negative 1 becomes positive 3 over 2x. And I'm going to do some scratch work. Negative 5 over 1 times negative 3 over 2. Again, don't be afraid of fractions, right? So this becomes 15 halves positive. And now, when I look at this line, which came from here, and the one I put here, I'm going to stack them right on top of each other. I notice they are completely identical in every way, and their signs. So my M1 is equal to my M2. My B1 is equal to my B2. We are the same line, so therefore we would be consistent and dependent. Yep. And then I also would put dependent. I can't spell today. Dependent, yeah. And then I would also say infinite solutions. All right. All right, so guys, I'm going to cut it there at 25 minutes. Zoom out of here. That's all the work that should be shown. It proves everything. It shows the classification. Go back over that slide if you don't understand it, and I'm going to move on to number 7.